Okay, this is lesson 7.1, graphing trigonometric functions, and we're starting with the graph of a sine curve. And for right now, what I'd like you to do is just be able to write down the definition, or just write down the definition in your notebooks for periodic function. And make sure that you say sine is a periodic function and the period of sine is 2 pi. I'm going to come up with a blank screen in a second where we are going to graph a rough version of 2 pi of sine of x ourselves. I wanted you to see what it looks like, and so here it is, and then I want to walk you through the process of graphing it yourself on a blank sheet of paper. You will have to be able to generate a graph of sine over a given interval pretty quickly with a limited amount of precision as we go through the rest of this course. I'm going to just get a blank screen, and we're going to graph sine on this blank screen. Please do this with me in your notebooks. I'm going to set up my x-axis and my y-axis first of all. And that x-axis should be the whole width of your notebook. I want to graph on the interval -4 pi to +4 pi. And I want to split that interval up first in half. So halfway between 0 and 4 pi is 2 pi. And then halfway between 0 and 2 pi is pi. And then halfway between 2 pi and 4 pi is 3 pi. And then I'm going to split those intervals up in half again. Halfway between 0 and pi is pi over 2. Halfway between pi and pi over 2 is 3 pi over 2. Halfway between 2 pi and 3 pi is 5 pi over 2. And then halfway between 3 pi and 4 pi is 7 pi over 2. These are odd multiples of pi over 2. The left-hand side of the left of the y-axis is going to be the mirror image of that. And you may want to pause the video to catch up with me. The maximum of the sine wave is 1, and the minimum is -1. The sine curve never gets any bigger or any smaller than those two values. Now, I'm going to graph my zeros. I'm going to start at the origin. The sine of 0 is 0, and the sine of pi is 0, and the sine of 2 pi is 0, and the sine of 3 pi is 0, and the sine of 4 pi is 0. And to the left of the y-axis, the sine of -pi, -2 pi, -3 pi, and -4 pi are all 0. The sine of pi over 2 is +1. The curve hits a maximum at that point. And the sine of 3 pi over 2 is -1. The curve hits a minimum at that point. And then every period, this cycle repeats itself. So at 5 pi over 2, there's a maximum, and at 7 pi over 2, there's a minimum. To the left of the y-axis, we're going to continue that pattern. So the sine of -pi over 2 is -1. and then that's a minimum, and then at sine of negative 3 pi over 2, we've got a maximum, and then at negative 5 pi over 2, it's a minimum, and at negative 7 pi over 2, that's a maximum. So now we're going to connect these points in a smooth sinusoidal curve. All right, so that would be about the level of precision that I would expect from you when graphing sine waves. You have to make sure that you've got all of your zeros, all of your maximums, and all of your minimums labeled. I'm going to go back to the previous screen and just take a look again at what a textbook version of sine looks like. Here I have one cycle of the sine wave going from 0 right here to 2 pi right here. That's outlined in the red dotted lines, okay? And it's important that you understand that the period of this function is 2 pi, and so you can see one cycle of that graph between 0 and 2 pi. And then if we take what that one cycle looks like and we move it to other positions on the graph, then it happens exactly the same thing in the next cycle. And I can move that to any place on the graph, and it overlaps the graph at that place. So on my next screen, I've got definition of a cycle of a periodic function, and I've got the picture of what one cycle looks like. Pause the video, write that down, graph one cycle, a rough graph of one cycle in your notebooks. The domain and range of sine. Okay. So the domain convention says that unless you're given evidence to the contrary, the domain is all real numbers. So we want to investigate this and see, are we given evidence to the contrary? Is there any place where you cannot evaluate the sine of x? All right, and this curve is continuous. You know, there are no places that the graph does not touch between 0 and 2 pi. And we've already said that that cycle will continue forever to positive infinity and to negative infinity. All right, so all of that tells you is that the domain of sine is all real numbers, and that's how you can write that. From negative infinity to positive infinity. The range are all of the values that y is touching on the graph. And we see that there is no value greater than 1 that this graph touches, and there is no value less than negative 1 that this graph touches. The only place, the only y-coordinates that this graph touches are those between negative 1 and positive 1. So the range of sine is the interval between negative 1 and positive 1. There it is, written as an inequality. And here it is, written in interval notation. Okay, this is a typical test question. All right, graph the function on the given interval between 2 pi and 6 pi. All right, so what I want to do is I want to first set up my axes. Now, we're not asked to graph any negative values. So I don't need to have the y-axis in the middle of the paper. I'm going to put my y-axis all the way on the left-hand side of the paper so I can graph all the positive values that it's asking me for. The largest value that I need to graph is 6 pi. And then I'm just going to break that up into pretty even intervals. I'm going to divide that in half and say, well, that's 3 pi. And then I'm going to divide that into thirds and say that's 1 pi, 2 pi, 4 pi, 5 pi. And then I'm going to break those intervals into 1/2. So here's pi over 2. And then we're going to do the odd multiples of pi over 2. So I've got pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. And we know that the maximum of sine is 1, and the minimum is -1. All right, we're only being asked to graph between 2 pi and 6 pi, so this is the interval over which I want to do the graph. And part of what I'm going to check for when I'm grading your paper is, do you understand what that interval means and where that interval exists? So don't graph anything to the left of that. Now, we know that between 0 and 2 pi, sine completes one cycle, and at 2 pi, it comes back to a 0. And there is a 0 at every multiple of pi. And again, since this graph is starting again a new cycle, the next half interval, the next odd multiple of pi over 2 after 2 pi is a maximum. So it goes to a maximum at 5 pi over 2, a minimum at 7 pi over 2, a maximum at 9 pi over 2, and a minimum at 11 pi over 2. So I'm just going to connect those points. All right, so that's it for this video. Again, this problem is typically something you'll see on a test. So make sure that you're able to do that freehand by yourself. All right.